Hello, this is Ben McGahee with McGahee Mathematics, and this is the first part of the series on systems of equations, where we're going to learn how to solve system of equations by graphing. So let's just say if we have, a couple of lines, and the way we would solve this system of equations by graphing is to look at where the two lines intersect or meet. And so the point of intersection, xy, the order pair, would be your solution for the system of equations. Now, there may be a case where you have, let's say if we draw another coordinate plane, xy axis, if we have two lines and let's say they're parallel lines, then this system of equations would have no solution because there's no point of intersection. These two lines, they do not touch or do not meet at any certain point in the plane. So we would say that this system has no solution. So in the first case, we had two lines. They intersect at one point. We say that would be the solution. And in the second case, we had two parallel lines. Those are lines with the same slope, and they have no solution. Now let's take a look at a third case. So let's say I have a line I draw here, and then another line is drawn that actually coincides, or basically just traces over the original line. Then how many solutions do you think this system would have? Well, it has at least one solution because there's some point where both lines touch or meet in point of intersection. But as you can see, there's several points, right, where both of these lines intersect. And since there's infinitely many points on both of these lines that trace over each other, we can say that that this system has infinitely many solutions. Right? So these are the three different cases, You have two lines that meet at one point. You have one solution. You have two lines that are parallel that don't touch each other. You have no solution. And then you have a pair of coinciding lines that just trace over each other, and then you have infinitely many solutions. So those are the three possible cases you're going to see when solving systems of equations, two equations and two unknowns. So let's get started just with an example to solve by graphing. Let's say if we have y equals 2x minus 1 and y equals x plus 2. So here are our two linear equations, and so we're going to graph both of these lines and see if they meet anywhere in the plane. So x-axis, y-axis. So just remember earlier the x-axis is the horizontal left and right axis. The y-axis is the vertical axis going up and down. Okay. So if we graph y equals 2x minus 1, let's look at the y-intercept. So we look at -1 is b, so we have 0, -1. So we'll plot that point. So we have 0 here. We go down 1. So there's 1 point. And then our slope is 2. So 2 means what? Rise over run. So 2 over 1. So I'm going to go up 1, or sorry, up 2 and right 1. Up 2, right 1. So I'm going to start from the y-intercept and go up 2, 1, 2, so up to 1, and then right 1. Okay. And then we can also go again, we could go up 2, 2, and right 1. So up 2, right 1 would be right here. So that's 3. Okay, so our line will look something like this right here. Now, for our next graph, we have y equals x plus 2. And we see that the y-intercept is b equals 2. So we'll have 0, 2. So 0 up 2 would be this point. And then for x, the slope is 1. So whenever you don't see a number in front, when it's positive, it's 1. So here we're going to go up 1 over 1. And then we keep going. So let's see. So we can go up 1 over 1 again. And then we'll go up 1 over 1 right there. And this would be about 3. Okay, so we can kind of see, where these two lines actually meet. There's a point of intersection where they meet. And it looks like the ordered pair would be at, we have x value is 3, y value is 5. So 3, 5 would be the ordered pair. Okay, so there is a way to check this algebraically, right? So you could plug in, this is your value for x is 3 and your y value is 5. You can plug those into both equations and make sure that the equations are equal to each other. So let's do that just for practice. So the first equation, y equals 2x minus 1. We have y is 5, and then that equals 2 times our x value is 3 minus 1. So we know that 2 times 3 is 6 minus 1 equals 5. And so 5 equals 5, so we know that that's true. So the first equation checks out. Yay, right? So we need to check the second equation, y equals x plus 2, or you can say 1x because the slope is 1. So x plus 2. We'll check that in this color. So y, remember, is 5. So we'll have 5 equals x is 3 plus 2. And 3 plus 2 is 5. So that checks out. So since both the equations check out, we see that our solution for this system of equations is 3, 5. 3, 5 would be our answer. Okay, so this has been McGahee with McGahee Mathematics on System of Equations, video number 1 with graphing. And just to recap, we just have a system of 2 equations, 2 unknowns, and we're graphing both of those lines to see if they have a point of intersection. And if we know they do, they have a solution. And if they're parallel lines, which was in our second case here, we know that they have no solution because they don't intersect or meet. The slopes are the same and lines don't touch. And then, of course, the last case, if you have coinciding lines, then you'll have infinitely many solutions where one line's basically the same as the other, tracing over each other. So do look forward to the next video, System of Equations number 2, where we're going to look at solving system of equations by substitution, a more algebraic method to solving system of equations. So stay tuned for that.